Hi again. In this video, I will quickly go over basic ideas in probability theory. The assumption that if you decide to study actuarial mathematics, the assumption that you have already solid background in probability theory. So most of you guys will, this review will find it very easy and it will go quickly. However, if you realize that this is something that is a bit challenging to you, or something that there is a gap in your knowledge, which is good, you can still go back to review the theory. I would suggest that you go for advanced probability theory and try to review the probability theory. So let me try just with skipping through the very basic ideas that we will use extensively in actuarial mathematics. So we usually, when we discuss probability theory, we start with defining the random variable. We look at or let's start with this discrete distribution. And let's define what we mean by random variable. Random variable is basically you assign a number to an outcome. So let's take one example to understand what we mean by this. Just let's flip not one coin, let's flip two coins. Flipping two coins. So if you flip two coins, you would have outcomes, right? I hope that you can still read my handwriting. In general, my handwriting is very bad, and it gets worse with electronic whiteboard. But if you flip two coins, you would have four different outcomes. One is head. The first one is head, and the second one is head. One is head tail. The other one is tail head, and tail tail. Right. So these are all the outcomes. So now the random variable, let's define it for this example, is the number of heads. So if the number of heads, and usually we give it letter X, number of heads here, we have two heads, 1, 1, 0, right? But you can see that 1 and 1, we can combine these two guys into 1. Now this is basically like the random variable, which is now X here, right? X is a random variable. In distribution, in probability distribution, is what another concept is probability distribution function. What we try to do in probability distribution function is to assign probability to each value of the random variable, to each outcome, right? To each X, right? So we want to provide a probability of X, and this is, it goes without saying, that each outcome of these will be 1/4, 1/4, 1/4. But since we have head, tail, tail, head, this one will be 1/2, this 1/4, and this will be 1/4, right? So this is the whole thing here. What we can call it is, this is like the probability distribution function, right? This is like the probability distribution function. So what I wanted now to start defining some of the rules of probability quickly. Rules of a probability. Rules of probability. The first rule you would, very important to recognize, always probability is positive. You cannot have a negative probability, like the probability it will rain tomorrow, it cannot be minus. So probability of X must be greater or equal to 0, right? And it should be bounded as well, greater than 0, but obviously less or equal to 1, right? The second rule of probability, that if you add up all the probabilities possible over X, they must give you to 1, right? You can verify here is if you add sum all probability of X, they give you 1, right? That's very, very basic. Now let's also, since we talked about this, let's look at define also what is the expected value of X. And you will see it written in Greek letter mu. Expected value of X, you sum all the X multiplied by probability of X, right? over x, right? I usually do it directly here in the table, so I write x px and then add them up. So x px here is you multiply the x is 2 by 1 4, so 2 multiplied by 1 4 is 1/2, and here is another 1/2. This is 0, and now let me use different colors so I don't confuse you. 1/2 1/2, so 1, right? So for our example here it will be 1, right? So mu, or the expected number of heads, remember what we defined our random variable in, on average our expected number of x will be 1. So another definition also is, what if we want not expected value of x, but rather, you know, expected value of any function. Any function, not x. It can be a function as well. It's the same logic. Instead of multiplying by x, you summation. This is summation of g of x multiplied by the probability of x. You sum over all the values, right? And then you find it. So if we take example of a function g of x, imagine g of x is x to 2, right? And we want to find the expected value, or expected value of x2 or g of x, right? We can do it directly into our table here, the same table, right? So instead of xpx, now you have x2 px, and again, you know, gx can be any function. So all you need to do, you take 2 to this 2, raise it to 2, it's 4, multiplied by 1 4, which is 1. Now 1, you raise it to 2. This one, you raise it to 2. You multiply it by 1/2 is, sorry, 1/2 here. Here is 0. So now if you maybe use another color, if you sum these guys up, will be 1.5, right? So what I wanted here to say that for our example here is 1.5. And why this is important, x to 2, because we will use it to compute something very important. Obviously, you know it in statistics, is this variance. So variance of x, right? Variance of x is, well, we use another Greek notation with sigma to 2. Sigma square is defined, and the easiest form for us to look at is summation of x to 2 px minus expected value of x, or mu, raised to 2, right? So since we already calculated, this one is 1.5, and this one 1.5, and we know that our expected value is 1, minus 1 to 2, this will give us 1.5 minus 1 is 0.5, right? What if we wanted to have another concept, which is the standard deviation? So this is standard deviation. Standard deviation, it's very, very important as well in statistics in general, in actuarial science in particular. Also we use it a lot. So in finance as well, so it's very important for us. So standard deviation from the definition is sigma. So we take sigma square, we take the square root of it, so 0.5, so it will give us 0.07, right? So, well, I don't know, maybe I'm live. It's just like also always to double check, use your calculator, right? 0.5 raised to 0.5 is 0.77, right? So this is like the basic idea of a discrete function. You can try another example for yourself as well if you wanted, you know, like to challenge yourself. Well, I mean, this is very easy. I know you've done it before, and many of you guys, you can skip through this quickly. But think about rolling a die. If you roll a die and define x is the outcome that you get, x will be 1 to 6, right? So can you find the probability distribution? Maybe I should write it here. So what I want you to first is the probability distribution function. I mean, I don't need to do it, but you guys do it yourself. So quickly, so we have x is 1, 2, the die have all the way to 6, and it has an equal probability of each outcome, which is 1/6, 1/6, all the way 1/6. We can doubly check, it should add up to 1, obviously 6 outcomes with the equal weight. So this is the probability distribution function. Now 2, what if we wanted to calculate the expected value of x? What is the expected outcome? I mean, you can have x multiplied by px. If you do that, it will be 1/6, 2/6, 3/6, 6/6, and if you add them up, it should give you 3.5, right? Because 1 to 6, it's 6 times 7, 40, yeah, it will be 3.5, right? 3.5. Now you can also quickly calculate variance of x. If you do that, I already computed, and you can verify it. So you need to do x2 px, sum them up, and then if you do that, which later on, I mean, you need to sum them up, and then if you do the variance of this one, it will be 6 raised to 2, we'll come back to this definition, minus 1 over 12, so 35 over 12. There is a rule for it, we'll take it in the common distribution later on, but just this is something you can do it yourself. You can also take sigma, which is the square root of 35 divided by 12, right? You can compute it yourself, right? So related to this as well, not to spend a lot of time on this, if again, as I mentioned in the set of rules for these lectures, if you feel I'm going fast, it's cool. All you need to do is you pause, then you take your time, you solve it, you write it down, and then you can get have me speak again. So I think it's useful to do it this way. So anytime you think I'm going fast, you pause me and take your time. And it's very important to calculate yourself. Everything makes sense when you listen to it, but it makes a lot of it helps you, prepare you if you solve lots of questions, and as you learn, you write down yourself. Right. So another rule I wanted also to talk about is if you have the if you define y to be a function, right? Like let's ax plus b, and a and b are constants. So y x is the random variable, and you define y to be a function of the random variable. You add some parameters. So if you do that, the expected value of y can be computed based on this one. So it will be a expected value of x plus b, right? Variance of y is simply a to 2 multiplied by expected value of x. You drop the b because the b is like it does not affect the variance, right? And you can take also sigma based on it. You can take sigma, which is the sorry, I need a bracket here. You can take sigma, which is square root of the variance, right? And this should be a, sorry, yeah, right? So let's take example here, quick one. Imagine that a company that sells pizza, and it happened that the number of pizza that they sell is a random variable, right? And we define it to be x. So the x they sell in a day, right? It's a random variable. On average, actually, they realized that on average, like over a long time, the expected value of x, let's say they have 50 deliveries, 50 pizzas every day, right? So what they also realized that the cost to produce each unit, cost of each unit of pizza that they sell, let's say that the cost it's $5 each, and every day they have to have fixed cost, right? You need to pay for electricity, rent, all those things, fixed cost. Regardless they sell or they didn't sell, they have to pay $100. Now, you know, based on this one, we can define what is the total cost of operations. Let's define it to be Y. And you can define Y to be, you know, how many units they sell, right? So which is a random variable. X, we know the average of X, but in terms of how many units they produce is a random variable. It can be 50, the average, but it doesn't have to be 50. It can be 49, you know, any number. So, but because we're talking about the cost, it's the cost per unit, which is $5 multiplied by X, and you add to it 100. This is the total cost every day, right? The total cost every day is a function. So what is, the question is now, what is the expected value of Y? It's simply 5 multiplied by expected value of X plus 100. So it's 5 multiplied by the expected value of X, which we said 50, and we add to it 100, so it's 350. Did I get it right? And this is $sign, right? Well, you might want to calculate the variance of Y for the cost, the variance of the cost. Now this is becomes 5 to 2 multiplied by variance of X, right? And this is according to the definition, right? So 5 to 2 is 25, and we don't have the variance of X, but assuming here, I should have given it to you when I said the expected value of X. Let's say standard deviation of X, you know, like X is a random variable. Let's say that the variance of X is 20. You know, like the units, they sell 50, but the variation of it 20, like the variance. So 20, so the variance will be 500, right? And you can take the standard deviation as well, which is the square root of 500, right? So like we talk few rules here. I mean, this is again, it's for you guys, most of you guys, it's a review. There is nothing in you. But the second last thing related to this discrete distribution, we have something called CDF, cumulative distribution function, and usually we have it f of x, capital letter, the f here, f capital letter, it's cumulative distribution function. So if you go back to our friend here, the same example, the first one we have here, flipping, where is it? Flipping 2 coins, right? If you go back to flipping 2 coins here, right? We take this distribution here. Remember, it's 2, 1, 0, 1, 4. Let's write it again. It's not gonna take us much of time. But remember that you flipping 2 coins, you have outcome 2, 1. Let's write it 0, 1, 2. And we said probability of x can be 1, 4. You have no heads at all as outcome, or we have 1 head, it can be head, tail, tail, head, so it's 1/2, and 2 heads, head, head, it will be 1, 4. We said always they have to add up to 1. So now the cumulative distribution function is simply is the is the probability of x, right? So it's probability of x less than like the probability of x capital letter less than a value of a small x, right? And let's take it by example. We can understand it easily. So now let's define what is f of x here for this example. F of x here can be, let's define it this way. If x is less than 0, okay, obviously the outcome will be 0, right? But if x is greater or equal to 0 but less than 1, right? So here, right? And the probability is 1, 4. Because it's less than a value, right? So it's a combination. This is a combination, so you need, not a combination, I mean you need to add up, it's cumulative, you add up. So now if x is less or equal to 1 but strictly less than 2 is not included, then 2 is not included. You add 1/4 and 1, it's the 1/2, it will be 3/4, right? And the last possibility is if x greater or equal to 2, this will be 1, right? So it's cumulative. And if you try to illustrate this function, if you have it try to illustrate it, then it would look something like this, right? So this is your 0, 1, 2. This is your x. This is the probability of x, right? So the probability of x here, if it's less than 0, it means different color. It's actually here, less than 0, it's 0 here. But the minute you hit 0, including 0, 0 is included, right? It's here. So it's here, it goes 0 up to 1, 1 is not included. This value will be here 1/4, right? But 1 is not included. The minute you hit 1, you will go up to here, right? It's a 3/4. And this is not included 2. And 2 here, you go, it becomes 1, right? And this is a cumulative distribution function. It's very useful. We're going to use it for other sessions. Last thing I quickly wanted to talk about, this is the discrete distribution. What about continuous distribution? And this is also very important for our actuarial mathematics. So continuous distribution, usually it's different from discrete distribution, that the probability of one little thing is 0, like probability of x equals a, it's 0. So you always define the probability of x between a and b. Remember, here it matters if there is equality or no equality, but here it doesn't matter if there is equality or not, because it's probability of one event is itself, probability of x equals one value, it's 0. So but usually we have to integrate here, it's from a to b of f of x dx, right? And this will give us the probability of like a defined between interval. So same rules apply. Remember, if you add all the probabilities, summation of all probabilities, but here we don't use summation, we use integration of all probabilities from negative infinity to positive infinity of f of x, this must give us 1, right? Always 1. Right? So let's take one example. Let's take this function f of x is x divided by 2, right? And to make it a valid probability function, it should be between x 2, because it has, if you integrate between all the interval, it must give you 1, right? 0 maybe 0 if it's otherwise, right? So now let's take a few examples on this function. So this is x to 2, this function f of x is x to 2. So what I wanted to start by finding the probability of x between 1 and 1.5. Let's do 1 and 1.5, right? Remember, it's the same logic. We said we need to take from a to b, 1.5. We take f of x, x over 2 dx. If let's do the integration for this guy. So it's x to 2 over 4 from 1 to 1.5. So this will become 1.5 to 2 minus 1 to 2, and everything divided by 1/4. I use my calculator. It's 2.5 minus, just 1.5 raised to 2. 1.5 raised to 2 minus 1. Yes, it's 1.25 divided by 4. It should be 0.3125, right? This is the first probability. Second one, let's say wanted to find B is CDF. Oops. CDF. Remember, cumulative distribution function, we usually say f of x, and the definition of it, it's now from minus infinity in general, this is general form, to x, we fu du. Just we use u for the general definition, right? So if we find f of x for our example, we don't have negative infinity. Our function starts from 0 to 2. But we start from 0 to x, and our function is x over 2 dx. So it becomes x to, x to 2 over, can I just delete this? Have to, let's do it the correct way. I don't know what happened to this. Let's see, let me do it again. So we have here x to x over, we have u over something with my eraser. Technology is great when it works. If it doesn't work, it's a challenge. So I wanted to say u over 2 from 0 to x du. Right, so it becomes u over 2 for 0 to x, so x over 2 over 4, right, for us here. This is our and this is, we have of course divided between x between 0 and between 2. Right. Let's take what is the expected value of x, and the same definition instead of summation for the discrete function. Now we do this one. Expect in general form is from minus to plus infinity x f of x dx, right? This is the general one. So for our case, remember, it's x over 2 the function, and we multiply it by x now, multiplied by x and dx. But remember that our like the domain is not from negative to positive infinity, it's actually from 0 to 2. So this will be x to 2 divided by 2, so it will be x to 3 over 6 from 0 to 2. If you do that, x 2 to 3 is 8 divided by 6, or you can simplify it 4 over 3. What if you wanted to do variance of x, sigma square, or var of x, right? The definition is same definition, is expected expected of x to 2 minus mu to 2, and mu to 2 is expected of x, right? So if we do this one, expected x to 2, so it will be x to 2 multiplied by x over 2 from 0 to 2 minus mu to 2, dx minus mu to 2 is 4 over 3 square, right? Right, this is, we already found it. So if you do x to this one, it will be x to 3 over 2 from 0 to 2 dx minus 16 over 9, right? If you do this one, it will be x to 4 divided by 4 times 2, 8 from 0 to 2 minus 16 over 9. So what if you take if you take x to 2 2 to 4, it will be 16 divided by 8, it will be 2 minus 16 over 9. 2, it will be 18 over 9, so this will be 2 over 9, right? Correct. So what I think we can stop here. I think we did a bit of calculation review. Next session we'll finish the review of probability, and then we can take on review of interest theory. In next session, what I will review is common, discrete, and continuous distribution distributions that are very commonly used in actuarial mathematics. We'll go quickly over them, and then the session after that will review interest theory to help us prepare for our first session on actuarial math. See you later.